So our goal today in CSC241 is to start content review and to take a brief look at some of the steps you will take for your first round of assignments and solution. So these are the learning outcomes in our module. And what I'd like to do is just take the first couple of them, and then we'll access the study guide and review that information together. But then I'm going to segue into a practical matter where you're going to want to take your personal technology and you're going to want to work hands-on with it to prepare it so that it's battle ready for the rest of the season. And there are some specifics about how to do that well. If you have a Mac system, you're going to want to tell me afterwards, shoot an email and say, hey, I'm working on a Mac, which is fine. The method to optimize your personal technology works differently for a Mac, okay? And we'll get into that in a little bit. So any questions so far before we start? So the first thing we're going to do is explain how digital computers operate and provide a common hardware example of such, and then discuss and relate important binary patterns reflected in the base 2 number system. That's about as far as we'll take it. So if we work with our online resources in customary fashion, we're going to click the header, go into references, and you'll notice something funny about the way we do our study guides. And everybody see revision 1, but the addendum says revision 1A. When you see, when we're shooting at a moving target, how long, I'm just asking everybody to respond, how long do cellular phone companies want you to work with your phone on average? What's the typical plan when you get a new phone?
2 or 3 years.
2 or 3 years. Give the man a cigar. Thank you. Yes, 2 or 3 years. And that's become the cycle for portable or mobile technology. And it's not too far from the cycle that's expected by industry when it comes to consumer or personal technology that's on a different level, like laptops and tablets, right? So they expect that they're hoping that in 3 or 4 years, it'll be slow, it'll get clogged up, you won't be able to use it effectively, and you'll just go out and buy a new one. Hardware by far is advancing at a much more rapid pace than software. Let me give you some practical terms to explain that. It is said that if automobiles had advanced the way that computer hardware has advanced, you could now purchase a Rolls-Royce Silver Cloud for 25 cents. You could drive it at 1,000,000 miles an hour, and a gallon of gas would last 10 years. That's the equivalent for what's happened in computer hardware over the last 40 years. There's a gentleman by the name of Moore who came up with a law. It's called Moore's Law. And it basically says, hey, every 18 months to 2 years, the capacity or capability of computer components will double. So what am I saying? An i7 processor or an AMD such and such, right? An AMD sledgehammer, 18 months to 2 years from now, they're going to come out with a new chip and it's going to be twice as capable. It's going to have that much more memory. It's going to be so much faster. And that's the progression, right? Now, what to do for you? You may have a budget. You may be using an older laptop, a borrowed laptop. And what we're going to do after we cover our first topics is to show you how to glean the most out of it. But I want to get back to this revision number. The revision numbers are really important. Before you take the assessment for the module, right before you take the assessment for the module, immediately prior to your engagement of the assessment for the module, do not pass go or collect $200 if you play Monopoly, and that's kind of old school. And so, does anybody play Monopoly anymore? Board games? Like if the power is out and nothing's working and you don't have network?
For sure.
Okay, some of you know what I'm talking about, some of you don't. there's a corner of the board where you can't pass go or collect $200. You go right to jail if you land on that, right? So the thing is you have a case. Good morning, Jeshorn. You might not have audio yet. Good morning, Jeshorn.
Good morning.
Good morning. Glad you could join us. Okay, so one of the things that I wanted to tell you is that we're shooting at a moving target. Hardware is changing all the time. And what will often happen is that we'll have a module study guide or an addendum. And as I get in there, I'm going to find out, oh, wait a minute, they changed this. That's no longer the case. The chips are designed differently now. This happens every other year. I have to update the content for this course every other year. And it happens on the fly. So before we post the assessment, I do a final check to see if anything needs to be updated. And I change the study guide and revise it and update it. Because sometimes I'm in class explaining a thing, and then one of the students catches me for additional credit. They Google something and they say, Professor Kentop, that stuff that NVIDIA does you were talking about, they don't do that anymore, right? And that's good. That's a win-win, because the student that finds that and calls that out and corrects me is helping me stay up with the industry. It is almost impossible to stay up with hardware advances every year. How many of you know that there 5 years ago was a new type of memory invented where you don't need RAM and hard disk? That doesn't exist anymore. It's just memory on a chip, and it's so big and it's so fast. You don't need RAM and you don't need hard disk because it's all the same memory. It's called 3D X-Point, and it has the potential to revolutionize hardware, because for 50 years we've been planning on building devices and computers in the same way, where we have hard disk persistent memory storing your data when it's powered off. Because let's face it, if the digital world is ones and zeros, and that depends on the pulse of electricity, what happens when you turn off the device? Right? You turn off the device, what do you got? Nothing. Unless it's stored in persistent memory. And that's what we call hard disks or SD cards, right? Everybody with me? Okay, so what happens if you have a device where you boot it up and you don't have to read the programs and software out of the hard disk to run the device, and those are loaded into RAM, which is faster operational memory. It's what the CPU works with, right? That model for computing was invented 50 years ago, or about that, by a man named John von Neumann. And what I'm telling you is that 5 years ago, there was an invention that could change everything that's been done for the last 50 years. And the industry is just figuring out, wait a minute, why do we have separate hard drives and memory? Why do we have a smartphone with separate memory in the phone, but then you also have an SD card, you also have separate memory. Oh, but now you have cloud memory, right? So think about it. You can rework the way these things are actually built if you understand those things. That's why we have revisions. And if you are sent a notice that an assessment is now available and you have 3 days to complete the assessment, please check. I will also usually email you the revised copy of the study guide, because we're changing it all the time. One thing you don't want to do is have a new version. You can download this. So this thing is set to download. You can click on it, then you can download it. You can have your own PDF copy of it. And the problem with this setup is, if you do that at the beginning of the module, and we've changed some things by the end of the module, if this is revision 1, it might be revision 1C, or it might even be revision 2. Now, if you see a whole number revision in a study guide, watch out. That means the revolution has begun. That means that we've radically changed the content of that entire module because of what we just discovered, what was just announced. And that's happening live in real time. How many of you know or seen the movie Terminator? Let's see if I'm batting a little better than Monopoly. Terminator? I need to hear from some folks who are with us virtually. Somebody unmute your microphone. Tell me if you've seen the movie Terminator.
The newer one, not the older.
The newer one. Okay. Was there something in the movie about a liquid metal guy that could change shape and he was the advanced Terminator? That's two. That's
Yeah.
Terminator 2. Everybody know what I'm talking about?
Mhm.
This just in. About 10 years ago, they figured out how to make chips out of something like liquid metal. So when you have a new design for a chip, you just rewire the chip. It's like that liquid metal guy. You command the codes to rewire the CPU, and you have a brand new CPU without having to take the chip out and put a new chip in. Holy buckets. I mean, think about that advancement. Microsoft seized that advancement and they put liquid chips in their data centers because they knew in 5 or 6 years they'd have to pull all of those boxes out of the data center and get rid of them and put all new boxes in there, right? And they said, this is stupid. Let's just recode the thing and watch that liquid metal go. Google, on the other hand, said, no, we have more money than China. So we're going to build data centers for Google with hard-coded, high-performance, specialized chips that do search engine stuff really, really fast and do data retrieval really, really fast. And so they hard-coded special optimizations for those chips so that they could have better, faster data centers and better response for their customers. The only problem is, clock's been ticking. A year or two from now, their stock is going to go because they're going to have to spend all this money to pull all those chips out, replace them. Why? Because Microsoft's going to have a bigger, better data center because all they had to do was click, wait for it, reboot, brand new CPU, courtesy of the liquid metal concept, right? And I'm oversimplifying here. So for those of you that have family members who are in computer engineering, my apologies. We'll explain more later in the course, I promise. Any questions so far? Any questions? Okay, so I'm going to update my roster real quick. We have some new folks in the mix. Good morning, Cordell. How are you? All right, so I want to take a moment to call out something at the very beginning of the first study guide. And this is a big deal. And I'm glad that more people have joined us because I don't want you to miss this. These links in the study guide, I told you that if it's in the reference folder, it's going to be on the assessment. It's going to be on the midterm. It's going to be on the final. If it's in the study guide, you have to know it. The study guide is a summary of dozens or scores or even more than 100 pages of your textbook, okay? So when we go to the trouble to put stuff in the study guide, I risked divorce in my home to put some things in plain English in a study guide, and I intend to use the heck out of it, okay? And I want you to do this. If there's a link, you need to click the link. You must click the link. You must spend the time to watch what's in the link. If there's a link in there, I know it's worth watching, and I wouldn't waste your time. If you click a link and it doesn't work or I waste your time, I want you to send me an email that says, Professor Kentop, you've wasted my time. This is old stuff. It doesn't exist anymore. In which case I owe you lunch or additional credit. But then I'll find the next version of the video that is worth your time. That's how we do this, all right? So you're going to click some things. You have a chance to go into Coursera and join a course. Now this is kind of optional, but I want you to know what it is and why it exists. The authors of your textbook offer a more advanced course. It's online, it's free, you can get additional credit. You build a whole computer with their tools. We're going to build components with their tools, but then we're going to work with virtual machines. We're going to take a slightly different route so we can cover more landscape by the end of this course, okay? For computer engineers in a computer engineering degree program, this would be like computer architecture 2. And then there'd be another round, which would be computer architecture, advanced computer architecture, right? There'd be a third level. I just want you to be aware of that. You want to be aware of the additional resources, and there's cool stuff in there. There's modules, there's additional information, including the ability to earn a certificate in computer architecture, and more importantly, there's resources, really cool videos on how this works and what it does, okay? Any questions before we continue? All right, so the self-organizing computer. Now, I want you to meet one of the authors. He is Jewish, he is Israeli. Both authors are Israeli. They are brilliant. They attended and graduated with advanced degrees from MIT, Massachusetts Institute of Technology. And they came up with, I think I told you that 5 years ago, you had to have a special software to design chips. They included it free with their textbook. They're giving it away open source. I want you to meet this guy, but I also want you to listen to what he says about the self-organizing computer and how it is possible, if you understand the basics, it's like building blocks with Legos, and then you go from there. And I want you to know now that they are using his material, not just at universities, but in high schools. And people are building entire computer systems from scratch, beginning with ones and zeros. So this is a click that's worthwhile. And I'm going to click on it to make sure the darn thing works. Because, oh heck, yep, I am not.
We can't hear the audio.
Yeah, we can't hear nothing.
Okay. Thank you for letting me know that. The audio in the classroom was there, but I don't think the microphones were picking it up. In any case, I want you to click the link at your leisure and listen to what he says about how this works. So his textbook is incredibly deep, incredibly complex from the very beginning. But what he tells you is plain English. I don't want you to freak out when you get the textbook or you get the online version and you start reading it and you're like, what am I doing in this class? Don't let your mind go there. What I will tell you is that by the time we end this class, if you go back and watch these videos, you'll get a warm fuzzy and you'll go, oh yeah, I know about that stuff now, right? So crawl, walk, run, all right? Crawl, walk, run. Let's continue. All right, so one of the things that's the most profound about computers is that they're incredibly simple systems under the hood. All right, now we all use automobiles that have a lot of rich features and they're very complex. When you look at the first automobiles that rolled off the manufacturing lines in the early 1900s, all they did was convert gas and air into motion, and that was it. And they didn't have seat belts. They didn't have dash panels with indicator lights. They didn't have sensors that tell you, hey, your seat belt isn't connected. But now we have seat belt indicators that tell you, hey, you better put your seat belt on. And that's computer architecture. There is a physical hardware component that saves lives in an automobile, and it works with ones and zeros. In order to understand how a computer operates, you have to think like a computer. Now, this is where it gets a little deep, but I'm just going to tell you, crawl, walk, run. You're going to hear that a lot. Computers either are on, there's a flow of electricity that represents the number 1. When there is no flow of electricity, there is a second value. It's off or 0. It's either 1 or 0. Those are the only numbers that you work with as far as computer hardware is concerned. Now, the scary part is your mind is capable of adapting and adjusting and understanding those ones and zeros. By the end of this month, you'll be able to look at a set of ones and zeros, 4 of them, and tell me what they represent. The number, the actual alphanumeric value, the Arabic numeral that it represents. We're used to using base 10 because we have 10 fingers and 10 toes. Well, most of us, okay? Every now and then there are genetic variations. We're not going to get into that here. The point is that we have 10 fingers and 10 toes. And so our number system developed around the number theory that we're familiar with. But computers only know ones and zeros. Now, ones and zeros also represent other values, polar values, opposite values. So instead of just being on or off, they also represent yes or no. And that's huge because we have a single value, a single bit. So when you have a single one or a single zero, in digital terms, you have what's called a bit, which is a contraction for 2 words that are actually more complicated. But in common parlance, we use the word bit. Bit is a contraction of the word digital integer, something like that. So a bit, oh, binary digit. No, that's what it is. My bad. I had a brain skip there. If you take the phrase binary digit and you condense it, you get the word bit. Now, if you take 8 bits, 4 of them together, you have a 4-column binary number. That's the same as having a number in decimal terms in the thousands. Okay, is everybody with me? So if you look at 1,000, if you look at 1,527 in decimal terms, there are 4 columns in that number. There's 4 digits in that number. There's 4 places in that number. If we have 4 binary places, ones and zeros, we call that half of a byte. Half of a byte in human terms is called a nibble. And that's literally what they call it. So a byte is 8 ones and zeros together, 8 places, ones and zeros. That's what creates what we call a byte, B-Y-T-E. And if you have half of a byte, they call that a nibble. All right, everybody with me? Now, computers turn on and off those ones and zeros. They flow electricity and cut off electricity extremely fast. Millionths of a second, billionths of a second. When you hear the word gigahertz, that's billionths of a second. That means a billion times a second. Gigahertz means ones and zeros are being switched off and on. That's how fast they are. The thing that you need to understand is that they're not big on a lot of characters, but they create all the characters we use with just ones and zeros, okay? When you're using CDs or DVDs, those are represented differently. They put a pit or a burn mark on the disc. So they burn with that laser a little spot on the disc that you can't see because it's so small, but that represents a 1. And the lack of a burn mark represents a 0. So as you spin the disc, you have burn mark, no burn mark, burn mark, burn mark, burn mark. That's like 1, 0, 1, 1, 1, right? That's what we're talking about. On or off. Traditional hard drives, if you've opened up a hard disk and you've seen, it's like records or CDs that spin and there's a little head that reads that. That's magnetic. It puts a magnetic mark or not a magnetic mark, and those magnetic signatures are the 1s and the non-magnetic are the 0s. So we have burn pits from lasers, or we have magnetic marks on a hard disk, a metal plattered hard disk. And on Friday, I'm going to bring one of those in here. I've torn one out and I'll show you the little platters and the little heads. It's like record needles. If anybody here do LPs, they're making a comeback. Have record players, it's supposed to be all the rage. No. No. Okay. Well, never mind that. Does everybody know what I mean by record player, LP? Vinyl? final disk or platter, it spins around, there's a
Yeah.
needle that, okay, that's what I'm talking about. But if you open up a hard disk, you have many of those, they're metal, and there are, they're called, servo is the name for the motor. So a fancy name for motor is servo. And then the actuator, that's a fancy name for head, right? The read head. So actuators and servos. One of the things that I want you to know about binary system that confuses a lot of people is that the first value of the binary system is not 1. I'm going to say that again because it's profound and it'll trip you if you don't remember this. There are 2 values in the binary system. You have to have 2 values in order for it to work. And the first value of the binary system is not 1. It's 0. Now, that is so profound, I want you to understand. When I go into my components on a computer system, I'm going to go to the task manager. Well, no, actually what I'm going to do is I'm going to go into here. Can everybody see my screen now still? On your system, I'd like you to follow along with me if you don't mind. Open up File Manager right down here on your taskbar. And then where you see on the left, it says this computer or my computer, I want you to select that. And then what I want you to do next, I want you to right-click, use the right mouse button to click where it says this computer or my computer. Now, in this classroom, I've renamed it so I know what I'm looking at. I'm on a lot of different computer screens when I'm in class. So when I'm on this screen, I want to know I'm in RT Park 129 on St. Croix. But yours is going to say this computer or my computer, unless you've changed your computer name because you're a hacker. But we'll talk about that later. If you select the manage option, here's what comes up. And this is the cool part. Inside the computer management console is a device manager. I want you to select that. Or actually, let's select disk management, because this is actually a better thing to go. I have a physical hard disk inside disk management. It's represented by this graphical object right here. But what's the first number of my only hard disk you see displayed on this screen? 0. Ethernet network interface 0 is the first network interface. Memory module 0 is the first memory module in a computer. Okay? So this is a pattern you're going to see over and over again. If you have 16 hard drives as a set on a server, the first disk is going to be disk 0 and the last one's going to be disk 15. And you're going to think, I got to look at the last disk. There's 16 of those. I'm looking for disk 16. No. In the world of hardware and computer engineering, you start with 0. Okay? And that's just one thing we want to cue you into. If you get that fixed in your mind, some of these things are going to be simpler as we go on. So there are changes in thinking that you have to work in order to get the finer points later on. And this is one we want to call out intentionally early in the course. The first number of the binary number system is 0 because it represents the first value, which is, okay, represented instead by power that isn't flowing, the lack of a burn pit on an optical disc, or the lack of a magnetic divot on a metal platter. Okay? Any questions? All right. So in our assessment, I'm going to try to trip some of you up. I'm going to ask you what's the number of this first device, and you're going to see the number 0 listed, and that would be the correct answer. All right. So in the 6 minutes remaining, any questions about what we've covered so far? One thing I want to call out to you is that the first part of the study guide usually has some supplementary information at first, but then does everybody notice how the student learning objectives are labeled A through J? Everybody see that? If you follow down in the study guide, you should see the same sections. So after the initial information, by the time you get to the bottom, you should start seeing section A, section B, section C, and that corresponds with the study guides. Now, that's the general way that study guides are organized. And what I may do is go through here and add those. Most of our study guides have those sections clearly defined in teal, okay? In this case, there are 7 pages, and here's what we know about students and learning. Some folks learn very well when they read. So if you read this study guide verbatim and it makes sense to you, you're good. But what may happen is that you come to a part of the study guide and you don't know what it means. And if I don't explain it in class, I need you to call that out and say, hey, there's this on page 2, this paragraph, what do you mean? Okay. So I'm always refining my study guides so that they're more complete and comprehensive and they read easier. Okay. So we start talking about number systems, and I use a comparison between the decimal number system and the binary number system. I'll let you read that on your own before our class on Friday. Be sure you read the next few sections before our class on Friday, okay? Now, let's talk about your assignments and submissions. Everybody knows that you have to submit something about the textbook at the end of this week, right? So I'm going to post an assignment that says, send me proof that you purchased the textbook, right? The other thing I'm going to want you to do is I'm going to want you to share with me what kind of hardware capacity you have personally as far as your technology. And one of the ways we do this is we ask you to capture some screenshots. And those are pretty simple to do. I'm going to demonstrate that here and now. One of the first things I want you to do is to open up the file manager. And I want you to adjust the view so that you see things and I see things the same way. You're going to select My Computer, and you're going to go up to the View menu. And from the View menu, you're going to make sure that item checkboxes are unselected, unless you love the checkboxes so much and it's part of the way you work. I would recommend turning those off if that's turned on by default, and you'll understand why when we get going. You want to make sure that file name extensions and hidden items are checked. And one of the nasty things about this menu is that when you select it or unselect it, when you click on it, the menu disappears. Everybody see what happened there? The menu just disappeared. So I'm going to go back to View, and now it's unchecked, right? If I click it again, oh, that stupid menu disappears. Did I actually select it? Well, let's see. The answer is yes. You have to keep going back to that menu. That's the only menu that works that way, I think. But I just wanted to tell you, no, you're not imagining it. Now, the other thing I want you to do is to go to Options, and I want you to hit the pull down, and I want you to go to Change Folder and Search Options. Everybody with me? You're going to select, and what's most important is you have to have My Computer or this computer selected when you do this. Because if you're in a folder, those changes will only apply to that directory or folder. We want it to apply to the entire system. We're going to change folder and search, then we're going to go to View again in a separate View tab. Well, we will leave the top box unchecked, make sure the next 4 are selected, make sure this radio button is selected, show hidden files, folders, and drives. And then we want to make sure the last 3, hide, hide, and hide, are unchecked, unchecked, and unchecked. All right. Click OK, and then we're good to go. All right. That's one thing you want to do. That means that when you open up, the other thing too is I would recommend that most times you view, when you go into a C drive, you want to show details. If you do this, if this is the view you have, it's going to be harder to keep up with the videos because I usually go this way with details. And if you have lots of folders and the icons are big, you're going to be scrolling down trying to find the folder, right? And if you use the condensed list, it's just easier to keep up. Okay? Everybody with me? All right, we're almost done. We are almost done. If you do not have a temp folder or directory on your C drive at this time, you will want to create one. So if you go from where it says this computer or my computer and you scroll down, you'll find devices and drives. You want to open up the C drive and you'll go to the white space in the window to the right, use your right mouse button and click. You'll select with your left mouse button the menu New, and you'll choose Folder. It'll pop up with the name New Folder, and you're going to change that to Temp with a capital T, lowercase emp, okay? Now I'm asking you to do this because I want to see how well you can follow along and do things click for click. It's going to gauge between us how fast I can move in the course to demonstrate things versus, okay, there's the thing. The other thing I would mention is I'm also recording this. So if you're following along and you get into the weeds on something, it's okay to call out that, hey, do that again. But I also want to encourage you to realize that, you know, I'm recording it. Now, if you find out that I'm not displaying the screen, it's not recording, or your screen is radically different than my screen, then you should raise a flag, okay? Because what we don't want to do is leave people in the dust. They're like, hey, it's really cool what he's doing, but I got nothing on mine that looks like that, right? I don't want to do that to you. All right, so in your temp folder, we're going to use that as a staging area for the software that you will download. In your first assignment, you will download what you need to run the virtual environment to create logic gates, chips, digital components from the author. You have to have a place to put them where you can work on them regardless of your login, okay? Some of you have administrative logins on your screens. Some of you have user logins, and your family members have administrative logins. Everybody's situation varies with the personal technology. But one of the very first important things I'm going to ask you to do is to show this screen here how much disk space you have. Everyone, this is one screen you will have to capture and submit. Now, to capture and submit it, once you have the screen you need as an artifact, you're going to select the title bar. We call the title bar of a window this part right here. And after you select it, you're going to hold down the Alt key on your keyboard, and then you're going to hit print screen on your keyboard. Now, what that does is that captures the active window. If you hold down the Alt key too long, the shortcut numbers will appear. So you want to tap it. You want to tap it and do a little faster by going like this.
It's not walking your house, just what I'm in for.
Hello.
Go.
Okay. Was there a question? All right. We're just going to tap the Alt key and the print screen key. Then if we go to Paint, if you don't have Paint on your start menu, you're going to want to search for it. Type Paint, right? All right, we're done in 60 seconds. You're going to open this up. If your screen is all white, you're going to want to move this to where it's a smaller X, and then you're going to paste. Does that look familiar? You'll save it as a JPEG. Everybody is saving as a JPEG. When you submit your graphics images, you do not submit a smartphone capture of your screen that's 16 megabytes large, and there's 10 of them. I will never be able to read them in time. It's too chunky. Everybody get what I'm saying? You're going to save as and use the JPEG option and give it a sensible name, like, okay, File Manager View. And then click Save, right? And there you have it. Any questions about how we capture a specific window? Now, if you want to capture the whole screen, you just hit print screen. So if I hit print screen now, and I do the same thing, I'll create a new one, right? And I paste this. Now I've got an image of the entire screen, and that's helpful sometimes. Save as the JPEG and so on, okay? Any questions about how we capture screens and we document stuff? Okay, when you have problems with a submission step, an activity, an assignment, your assessments, oh, the assessment, the test blew up while you were taking it. You're gonna want that print screen, you're gonna want to capture those things. When you send me a notice that says, hey, I can't get in, hey, this isn't working, hey, my screen is different, print screen, print screen, print screen. Everybody got it? Because that way I can get a bird's eye view of what's going on, and oftentimes we can resolve it much quicker. All right, this concludes our session today. I appreciate your patience with the late start and the late end. We will end on time on Friday. We will start by 5 after 10 on Friday. I'm going to stop sharing and stop recording.